My goal is that when you see a picture like this on a geometry question, you know exactly which topic it is. And it is not a topic where we really have anything to help us from the reference chart. Maybe area and circumference formulas for a circle, but this is what I would call a part over whole question, where we make fractions, because we want to think about a sector of a circle, right? So we're talking about how this sector behaves, whether we have it's a certain fraction of a circle. So there's lots of ways we can deal with this, but the idea is that when you see a circle, or they describe a circle, and it's got a slice, a part that we can kind of like anchor on the center of the circle like this, like a slice of pizza, then it's going to basically involve this same process. So get used to this process. This question does have other ways of solving it, but I really like when we have just a process that works no matter the type of question, instead of having a million different processes for every single type of instance that could happen. And the reason that this part of our whole formula works is when I learned circle sectors in school, I believe that I had lots of different formulas. One for the sector area, one for the sector arc length, one for the degree measure, the radian measure. Part of our whole works no matter what it is. It's just about setting up a ratio to compare the different aspects of the circle, the part that we want over the whole for that circle. So we are given two different kinds of things. We are given angles, so we have 100 degrees here. And then we are also given an arc length of 5 pi for ADC, so that's this part here is 5 pi. So we have a way of representing the part of this piece is 100 degrees, right? So we could think of it as, you know, that's the opening, the angle. The opening angle is 100 degrees. And we have to go with the central angle because that's the one that has a hole that we understand very easily, which is 360 degrees in a circle. So that's what we're doing. We're setting up a way of like understanding this fraction, right? So this slice, it's 100 360ths of the circle, 100 degrees out of 360 degrees. Now, the good thing about these sectors of circles is they're consistent. So whatever fraction that is, it's going to be the same fraction for the arc length. So we can set up another part over whole with those aspects of the circle. So the 5 pi is the part we care about. We don't know the whole, but it's the circumference of the circle, right? It's the whole way around. If 5 pi is part of the way around, then the whole way around is whatever the answer is, but also that's called the circumference of the circle. So what this allows us to do is just cross multiply and divide pretty easily. Sometimes you can just see the ratio, but I'm just going to do it. So 5 times 360, let's go in here. 5 times 360 is 1800, so 1800 pi, divide by 100, divide by 100, and the circumference is 0.000018 pi. And is that an answer? Choice C, yes, but that's a trap because that's not what we want. And this is where, you just always got to be careful with any geometry question, right? What do they want? They want ABC. Now that's this arc here on the other side. So if the full way around is 18 and we have 5 already accounted for, then 18 minus 5 is 13. And of course, there's a pi on all that, but then we're done. B is the actual answer. So it's not really that bad if you messed it up because you didn't pay attention to what the question is saying. Shame on you. If this is your first geometry question of mine that you're seeing the video for, then I guess maybe you have an excuse. But I talk about this a lot with geometry, that they purposely have these mission accomplished traps where they know what we're going to solve for naturally, and then they specifically ask for something different, knowing that all we have to do is maybe add 2 numbers together at the end, or in this case, subtract. But like, they know that we're just going to get so excited when we have x equals a number that we just don't do that, especially when it's an answer choice, the thing we just found, right? So you got to always, with any geometry question, but really any SAT question, make sure you're actually giving them what they want, not just what you think they want, not just what you're used to giving them. So if that's the reason you got it wrong, that's really bad. That will happen again and again on every SAT, waste of points. But if you got it wrong because you didn't really know where to start, this part of our whole thing is really useful. It is one of what I think of as like the fundamental geometry formulas. It's not given in the reference chart, but it's a really useful way to think about sectors of circles. It just works in all these different cases, and it really does help you just kind of work around complicated shapes. A lot of hard geometry questions will still test this part of our whole thing, but only as like a part, an aspect of the question. It'll be one step and the process will be more complicated. So it's a really important one to know for some of the hardest geometry questions.